Good morning. I woke up to a sick kid this morning, so I will not be there today, but I am going to walk you through some questions from the homework because 7-4 tends to be the trickiest, and then teach you 7-5 because you have a test on Friday. So the test is pretty short. So I will have a little bit of time at the beginning of class on Friday to just answer a couple of questions. But I will also try to be there, assuming that Mackenzie is healthy at that point. I will try to be there at 7:40 Friday morning if you want to come in and ask any questions, okay? So I'm going to walk you through a few of the questions on the homework. So if you don't already have your homework out, you can pull that up and see how you did on these. And then hopefully I cover the gist. The ones that I go over are the ones that you should know how to do. So that should be good news for you. And then I will teach you 7-5. So here we go. The first thing is find the geometric mean of something. So like 12 and 14 here. Basically what you're doing is you can treat it two ways. I showed you a shortcut way and I showed you just the general setup. Remember, geometric mean looked like this. A over x equals x over b. The a and the b are the numbers that you're given. So you can set this up as 4 over x equals x over 10 and then cross multiply it. So x squared equals 40. And then we take the square root of both sides, and that needs to get broken into simplest radical form. So you are looking for a perfect square and a non-perfect square that will work here. So that's going to be 4 times 10 gets you 40, and the square root of 4 is 2. The square root of 10 we can't break down, so x comes out to 2 rad 10, okay? So that's one option. The shortcut is whatever numbers you get, you multiply them together and take the square root. And wouldn't you know, that is the square root of 40. So it's just doing this process without having to set it up, right? You multiply them and take the square root. It will still break down to 2 rad 10 in the end. Okay. I think people sometimes get a little nervous about this one. It's the same thing, right? You multiply them together. So square root of 8 times square root of 2 is the square root of 16. And then you take the square root, which I think is why it's tricky. The square root of 16 is 4. So this is the square root of 4, which is 2. So don't let that radical within a radical confuse you. Just do the process. Okay, then I'm going to do... for sure number 18 with you because that has both setups. I'll probably do 18 and 20. Yeah, let's do 18 and 20. Okay, so if you are the type to draw the triangles, remember we set it up like this. The smallest triangle, the medium triangle, and the biggest triangle, but all from the same perspective. So the shorter leg being vertical, the longer leg being horizontal, okay? So that we can just set it up as similar triangles. So if we take this setup, your shorter leg, right, here's your right angle. So in the small triangle, let's go pink so you can see what we're looking at. Here's the small triangle, okay? The shorter leg is 3. The longer leg, because here's the right angle, okay, the longer leg is y, and then the hypotenuse would be this side, and we don't know that side, so you just leave it like that. Okay, in the medium-sized triangle, it looks like this. You have this right angle, so your shorter leg is y, your longer leg is 9, and your hypotenuse is x. And then in the biggest triangle, okay, so here's the big triangle. This is the right angle. These mean nothing in the big triangle. You can ignore those in the big triangle. In that big triangle, we don't know our shorter leg. our longer leg is the x, and then the hypotenuse is the 12. Okay, so these are your three triangles. Once you have those laid out, then you just need to find the parts that correspond. So for instance, if I'm solving for x, okay, I have an x here, and I have an x here. So it looks like we're probably using the medium and the large. Let's see if we have corresponding parts on those two. So this is the hypotenuse, so that's got to correspond to the hypotenuse. This is the longer leg, so that needs to correspond to the longer leg. Okay, so I'm going to set this up. Longer leg over longer leg equals hypotenuse over hypotenuse. Okay. From there we can cross multiply. So x squared equals, that's 108, I believe. Yeah. And then we take the square root of that. Okay, so when you square root 108, first plug that in. Is it a perfect square? It's not. But we can break it down into a perfect square and a non-perfect square. Let's see here. 108, I think that's divisible by 36. So you just think through your list of perfect squares. 36 and 3 gets you 108. So simplest radical form here is 6 times the square root of 3. Okay, so that's your x value. Then you also need to solve for your y value. So let's take a look. Y is here. Okay, there's also a y here. So in that setup then, it looks like we're probably ignoring the biggest triangle. Let's see if we have corresponding parts here. So this y would correspond to the 3. This y would correspond to the 9. Okay, so think of it this way. Shorter leg, I'll go pen. Shorter leg over shorter leg, 3 over y, equals longer leg over longer leg, y over 9. And then we'll cross multiply that. So y squared equals 27. If we take the square root of that, that's going to be the square root of 9 and the square root of 3. So y equals 3 times the square root of 3 for that one. Okay. And then number 20. Okay, so your smallest triangle, I'm going here. This is your right angle. So you have 4. The longer leg is the y. And then the hypotenuse across from the right angle is the x. The middle triangle is this guy, which is going to flip over. So your shorter leg is the y. Your longer leg is the 21. And then the hypotenuse across from the right angle, we don't know. And then the biggest triangle, you have, we're flipping that around, okay? So the right angle's here. You have a shorter leg of x, a longer leg that's unknown, and then the hypotenuse is where you got to be a little bit careful, right? Across from the right angle is this whole thing. So 21 and 4 put together, or 25. Okay. Okay, so we're here. We're going to match up the corresponding parts. So if I'm going to solve for x, here's an x, here's an x, okay? You're going to set that up. This x would correspond to the 4. This x would correspond to the 25, right? So this is a shorter leg over a shorter leg. So 4 over x equals x over 25. Okay, when you cross multiply that, you get x squared equals 100. and then we take the square root. So x is 10 on this guy. Okay. Then we're going to solve for our y. And for this one, you have a y here and a y here. So this longer leg would correspond to longer leg. This shorter leg, would correspond to the shorter leg. So when you go to set this up, it's going to be shorter leg over shorter leg, 4 over y, equals longer leg over longer leg, y over 21. And then we're going to cross multiply that. So y squared equals 84. And then we're going to square root that. And the square root of 84, the perfect square that 84 is divisible by is 4 and 21. So this is going to be y equals 2 times the square root of 21. Okay, so that is just a little bit of going over the homework. Okay, go ahead and get your notes out, and we will do 7-5 together. All right, so the notes look like this. And we got a couple theorems to talk through today. Still dealing with proportions. And I think if you can just get in the habit of how these get set up, they're pretty similar all the way through. Excuse me. So the first theorem we're going to talk about is called the side splitter theorem. Okay, this says if a line is parallel to one side of a triangle, okay, so look at BD here. If these are parallel, okay, so parallel to one side of a triangle, and intersects, so goes through the other two sides, right? So it hits this side at B, it hits this side at D. So if it's parallel to one side and cuts through the other sides, then it divides those sides proportionally. Okay, here's how I would lay it out if I were you. Let's just call this X and Y and W and Z. Okay, I always tell people when you set up this proportion, if you just extend the parallel line, it kind of makes the fraction for you. You're going to go X over Y, the ratio, and you're going to set that equal to, over here, W over Z. Okay, so it's creating this proportion for you. I'm not going to make you do this because I feel like you're going to run short on time as it is today. So we're just going to jump right into how you set it up. This is more just a proof of why it works, but we're going to skip it because it's not as important as the rest of this. So side splitter theorem, okay? The lines are parallel. Notice these are not equal. It's not that these two are equal in length. It's that the relationship between them will be the same as the relationship between these, okay? So we're going to set this up as a proportion. If you just extend those lines, right, you can see the ratio happening. This is 1, 12 over x plus 1 should equal, and if I start top and go to bottom, then I got to start top and go to bottom again. 9 over x, okay? And then from here, it's just cross multiply. So this is 12x equals 9 times x plus 1, okay? So 12x equals 9x plus 9, okay? Take away that 9x, so 3x equals 9, and divide by 3, and that means x is 3. Okay, so that's the side splitter theorem. Basically, the line that is parallel, if you just extend it, will turn it into a ratio and a ratio that you set equal. Okay, so you're setting up a proportion. And then there's this little add-on to the side splitter theorem where, notice up here, okay, it was a triangle that we were splitting. It doesn't have to be a triangle. Basically what it says is if all of these lines are parallel. Notice again, AB is not the same length as BC. Okay, those are different lengths. That's okay. As long as the lines are parallel, you'll get a proportion here again. So let's say this is G, H, I, and J. Okay, the setup would be G over H equals I over J. Okay, so you get this proportion again. So take a look at how that would be applied here. These lines are parallel. Okay, again, if you extend the parallel line, you can see your ratio. So this is one ratio, this is another. Now, it is up to you which one goes on top or bottom, but you have to stay consistent. So if I'm going to say x over 62, okay, I went left to right, then I have to go left to right again. So 70 over 56. But properties of proportion say you could have done that the other way. I could have gone 62 over x, but then I got to go 56 over 70. Okay, so totally up to you which one you like better. This is just a cross multiply setup. So we're going to go 62 times 70. Okay, that is 4,340. And then cross the other way, that's 56x. So divide by 56. And you get x equals 77.5. Okay, so that is the side splitter theorem. It's just set up a proportion and solve. Okay, the other theorem we're going to talk about today is called the triangle angle bisector theorem. And basically what it says is this: if AD, so if this segment here bisects, remember that's making two equal angles. Okay, so if it bisects this angle CAB, then, okay, now here's the thing again. If you take that line, that bisector, and make it like a bar, okay, it'll give you your ratio again. So CD over DB will equal, okay, so this piece over this piece. If I went, notice it's kind of like two different triangles here, right? You have this triangle now, and you have this triangle now. Okay, so if I started here for my top, then I got to start here for my top on my other one. So AC over AB. Okay, so notice it's always the two that are on the same line that you will put over top of each other, CD over DB, and then just follow the order that you went in. Okay, let me show you here. So here's your angle bisector. Okay, if we draw that in, you can treat that like a division bar. 9 over 15. Okay, the two that are on the same line will be creating your scale factor. So 9 over 15 equals, now I went left to right, so I need to go left to right. Okay, and then we'll cross multiply that. So 15 times x equals 25 times 9, which is 225. And then we'll divide by 15. Okay, divide by 15 and you get 15. So x would be 15 for this one. Okay, so you're just setting up a proportion. I'm going to draw one more for you here. So if I do the angle bisector here, notice this is just laying on its side, but I just want you to see with some letters. If this is A, B, C, and D, okay? If I extend that, here's my one ratio, A over B, and that will equal, so if I started at A, then I got to start at D, D over C. Okay. So that is the triangle angle bisector theorem. And that is really the two main concepts, the side splitter theorem and the triangle angle bisector theorem in 7.5. So 7.5 is a pretty short lesson, which is lovely to get ready for the test. So for the rest of the class period, what I want you to do is you're going to watch the video of the in-class Chapter 7 review on your own. So you'll get earbuds out and watch that video if you want. If you want to just try it on your own and then just refer back to the video to check your answers, that's great too. You're also going to submit your Chapter 7 notes now that they're done. So there's a spot in Canvas for that. And then there's an optional Chapter 7 review if you want extra practice problems. There's also a practice quiz for 7.4 that is optional, okay? You don't have to do that one. I posted an answer key to that one. It's just a couple extra practice problems of 7.4 because 7.4 tends to be the more difficult thing for people typically. So there is an optional practice quiz. There is a in-class review that you have to do. And then there's an optional Chapter 7 review. So if you're like running out of things to do, which I doubt you are because there's a lot going on today, you can do any of those three things, okay? But you must do the in-class Chapter 7 review. If you have to choose something else, I would pick the practice quiz 7.4. You won't submit that. You won't submit the Chapter 7 review, just the in-class review will get submitted, okay? So turn in your Chapter 7 notes. Turn in the in-class review by Friday morning, by the time of your next class period. And then the test will be Friday. I hope to be there Friday. My goal is to be there at 7:40 to just be able to answer anyone's questions that you have. But I will also be able to answer a few questions at the beginning of class probably on Friday because it's a pretty short test. So have a great rest of the day and reach out if you have questions. You can email me. Hopefully it all's making sense. Have a good one.